Nothing is happening, right? Two chemicals just mixed. No color, no bubbles, nothing. But something is happening. You just can't see it. The molecules are already reacting. Colliding. Rearranging. Breaking and forming new bonds. All happening at once. And spreading faster than you think. But your eyes miss it completely. Because it's transparent. And incredibly fast. No bubbles. No color. Just energy moving through liquid. Hidden in plain sight. Until you know where to look. Now watch this closely. There it is. The moment the invisible suddenly becomes visible. The reaction doesn't just happen then. It spreads outward instantly, faster than your eye can track. A thin boundary forms, separating what has already reacted from what hasn't yet. And then the motion begins to fold into itself, creating complex internal structures. Streams stretch, break apart, and reconnect to warmth, constantly reshaping the flow. What started as a smooth expansion quickly becomes unstable and unpredictable. Energy concentrates in certain regions, forming brighter, more intense zones. And when that energy peaks, it releases in sudden, almost invisible pulses. The reaction accelerates, spreading deeper and faster through the liquid. Order disappears, and structured layers collapse into chaotic motion. At the edges, instability creates branching patterns that push into the surrounding fluid. These structures look almost unnatural, yet they are driven entirely by physics. If you follow just one path, you can see how the reaction travels through the liquid. It splits into multiple streams, each moving in a slightly different direction. And then those streams collide again, merging into even stronger regions. Small vortices form at these points, spinning rapidly and redistributing energy throughout the liquid. Differences in density and composition begin to shape how everything moves. Gradually, the system starts to slow down, approaching a temporary balance. But even when it looks calm, subtle motion continues beneath the surface. And then, unexpectedly, a second wave appears deeper inside the liquid. This phase behaves differently then. Less uniform, more chaotic, harder to predict. Now both reaction fronts interact, interfering with each other's motion. The result is a dense network of overlapping patterns, constantly evolving. All of this complexity, created by a reaction you couldn't even see at first. What you just saw might look chaotic, but it follows very precise rules. At the core of it, this is diffusion, kernvy, molecules moving from high concentration to low. Every molecule is in constant motion, even when the liquid looks completely still. When two solutions meet, their particles begin to mix instantly. But the reaction doesn't happen everywhere at once, it starts at the interface. This thin region is where molecules collide and transform. And as the liquid moves, those reaction zones are stretched and distorted. That's how smooth flow turns into complex patterns. Small vortices form, constantly redistributing energy and matter. Differences in density push the liquid to move in unexpected ways. Over time, everything begins to even out. The system moves toward balance. But even in this state, motion never fully stops. Because at the microscopic level, everything is still in motion. And the reaction continues, just beyond what you can easily see. Which brings us back to the question. But what happens if we change just one condition? Lower the temperature, and everything begins to slow down. The same reaction still happens, but the motion becomes more controlled. Diffusion weakens, and the reaction front stays more stable. Chaos gives way to structure. Now increase the concentration. The reaction becomes faster, sharper, more intense. Energy builds up and releases in rapid bursts. Now change the geometry. The reaction no longer spreads evenly. Gravity begins to shape the motion. Patterns stretch, distort, and reorganize. And under perfect conditions, everything becomes predictable. A perfectly balanced reaction, revealing the underlying order behind the chaos. And now, it looks like nothing is happening again. But you already know that's not true. Because even now, the reaction hasn't fully stopped. At a microscopic level, molecules are still moving, colliding, and transforming. What looked like chaos was actually a system following precise physical laws. Every pattern you saw had a cause, even if you couldn't see it at first. From the first invisible interaction to the most complex structures inside the liquid, all of it was there, hidden inside something that looked completely still. And once you've seen it, you can't unsee it. Because nothing in this world is ever truly still. But what if the reaction didn't just stay invisible? What if it suddenly became visible all at once? A reaction that starts the same way, but ends in something completely different. In the next video, you'll see a reaction that reveals itself instantly and behaves in a way you weren't expect. Subscribe and don't miss it.